Okay, tonight we're going to begin looking at similarity transformations. In ninth grade, you studied translations, which is a slide, left or right, up or down. And you also studied reflections, which is going to flip it over a line of reflection. It could be the x-axis, it could be the y-axis, it could be a line. You also talked about rotations. Remember, you rotate in 90 degrees, 180 degrees, 270 or 360. And then we began talking this year about dilations, which is you're going to make it larger or smaller by using a scale factor. Now, when you do any of these transformations, it does produce similar figures. That's why it's called similarity transformations. A similarity transformation is a transformation in which the image has the same shape as the pre-image. Remember, it can be larger or smaller, but it has to be the same shape. A translation, whenever you discuss a translation, be sure to include how far it shifts left or how far it shifts right. So talk about the number it shifts left or right, or the number it shifts up or down. That's how you're going to describe a translation. When you describe a reflection, be sure you include the line of reflection or what you're reflecting about. Over. If you're going to talk about a rotation, you need to tell the degrees and the direction, if it's clockwise or counterclockwise. And if it's a dilation, you want to talk about the scale factor. All of those need to be included in your descriptions of the similarity transformation. So here's our first example. We want to look at the figure. Let's say that JKL is going to be my pre-image. This is my pre-image. And let's say that MNN is going to be my image. Remember, your pre-image comes first, your image comes last. The first thing you need to do if you're going to talk about similarity transformations is look and see if you think the pre-image is similar to the image. And if you look at the pre-image and the image, I can tell that they're not similar because the angles aren't going the same. So this would be no similar transformation. Or we'll say not similar. All right, let's look at the next example. Here, if the pre-image is going to be triangle RTS, that would be here, and the image is going to be XZY, which would be here. If I look at them, they do look similar to me. The angles look the same, the sides look proportional, so I would say what sort of transformation took place? To me, I can tell that RTS is much smaller than XZY, so I know that that transformation is going to be a dilation. And remember, if my transformation is a dilation, I need to tell the scale factor. And to me, the easiest way is let's look at the pre-image. One side on the pre-image has 2 units, and one side on the image is going to have 1, 2, 3, 4, 5, 6 units. So the scale factor, what do I need to multiply the pre-image by to get the image? That would be I need to multiply it by 3 because 2 times 3 is 6. So I've identified my similarity transformation. All right, here's another example where we have multiple transformations. So let's identify the pre-image as A, B, C, D. And let's identify our image, which is going to be E, F, G, H. The first thing I see is I see that definitely it has been dilated because the pre-image is smaller than the image. So I would say that it's definitely had a dilation. But it's also been flipped, so that would also include a reflection. So I've had 2 similarity transformations, okay? Remember, if you're given a dilation, you want to talk about the scale factor. So my scale factor here, if I look at one side, I have 2 units on AB. If I look at the corresponding side, which would be EF, 1, 2, 3, 4 units. So 2 times 2 is 4, so my scale factor would be 2. If I'm going to talk about the reflection, I need to say what it's reflected about, and the line of reflection's got to go in the middle of them. So that would be the x-axis. So don't forget, when you're describing similarity transformations, you've got to be descriptive about how it's dilated or how it's reflected or how it's translated. We'll work more on these tomorrow.